All right. We will get started here. I would like to welcome you all to our webinar, Preparing for Austin's On-Site Water Reuse Ordinance, a deep dive into Greywater technology and regulation. My name is Chelsea Wolf. I'm the Director of Marketing at Epic Cleantec. I'm delighted to be here with you all today to discuss an important topic that affects us all. As we know, water is a finite resource, and it is crucial that we take steps to conserve and reuse water whenever possible. On-site water reuse is one of the most effective ways to do this goal, and it will have a significant positive impact on both the environment and our communities. Today, we'll be discussing the benefits of on-site water reuse, including its potential to reduce water demand, lower utility costs, and create resilient buildings of the future. We'll also explore the City of Austin's upcoming water reuse ordinance and what that may mean for your business. Finally, we'll take a look at the permitting process and what resources may be available for you. Now I'd like to introduce our speakers. Eric Huff is Chief Commercial Officer at Epic Cleantec and is involved with the business development and project delivery initiatives out of our Southern California office. He holds a bachelor's degree in environmental engineering from The Ohio State University and has 15 years of experience in various water reuse applications, spanning mega municipal water recycling, wineries and breweries, to the Living Building Challenge projects for tech campuses. Eric is well-versed in technology, regulations, and integration strategies that enable buildings to become net zero water users. Megan Thomas is Epic's VP of Operations. She's held positions spanning engineering, project management, and global operations. Megan brings broad organizational experience to her work at Epic. She fuses her passion for real estate, resilient design, and water stewardship to accelerate the adoption of sustainable infrastructure solutions. She currently serves as the co-chair of Water Reuse Committee at the Water Environment Association of Texas. I encourage you all to actively participate in the discussion by submitting your questions or comments throughout this webinar in the Q&A section. We'll leave time to go over these at the end. Thank you again for joining us, and we are excited to engage with you and share our knowledge of water reuse applications and regulations. Eric?
Great. Thank you, Chelsea, for getting us started. Thanks everyone for being here with us today. Eric Howe, Epic Cleantec. We are a technology provider of all things on-site water reuse. So whether that's gray water, black water, or very simple stormwater, rainwater systems, our goal is basically to come to these development projects and find ways to conserve water. Frankly, we're in this space because we believe that no water should be wasted. The term itself, wastewater, is somewhat objectionable when you consider the pressure that so many of our communities are under out here in the West. You're seeing here a graphic that kind of gives you the big picture in terms of the state of our water resources, just the tremendous just square footage of our country, right, is under a lot of pressure here. And we're seeing more and more cities coming up with creative ways to help bridge the gap in terms of how much water is available naturally, and then balancing that with the water we need for our communities, for our businesses to thrive. So for us, there are a number of drivers here in this industry. Obviously, water scarcity is chief among them. Additionally, there's a lot of unforeseen, less obvious drivers, such as aging infrastructure. If you look around the country, we have around 1.6 million miles of water and sewer mains that are buried under our streets, just in North America alone. So a tremendous amount of infrastructure. The average age of that infrastructure is nearing 45 years. So you start to take into account the average service life, we're starting to see this windfall investment that's needed in all this civil infrastructure, which is now placing challenges on some property owners who go to the sanitation district in certain cities. This may not be the case in Austin, but I'm speaking broadly, where they don't have capacity to manage the wastewater emanating from high density developments. We see a lot of that specifically in the Bay Area, but it does kind of range geographically. So, for us, there's something we can do about it. There's a number of drivers that are also very relevant to a building owner, right? It's about making these projects pencil chief among them, right? the return on investment. We are finally in that sweet spot where we can hit that 5 to 10-year ROI for larger buildings. Of course, there are regulations, and that's what we're here to talk to you about today, that either incentivize or mandate, depending on the city. And then, of course, sustainability. And we'll talk to you in terms of how we can help you get to that next level of LEED certification here today. So, that's the big macro picture. We love to use this quote from Bill Gates, but, the basic premise is that we're building a tremendous amount of new buildings, and we all need to ask ourselves, what does the building of the future look like, right? How can we design these systems to be more resilient, more adaptive to the local conditions? And especially when it comes to your plumbing systems, those things are very hard to modify. There's a lot of fixed infrastructure that needs to be planned for in your building. And so, you kind of get one shot. Yes, we can do retrofits, but they're more costly, they're more complicated. And that's what's really leading to some of the, agencies adopting incentives or ordinances to mandate these technologies, because we all know we want to future-proof our buildings. So in terms of how we help specifically here at Epic Cleantec, as I mentioned, we are a technology company at our core, and we focus on taking the waste out of wastewater, right? And so there's three key outputs that we are currently focused on. There's the water that can be recycled up into the building for non-drinking applications like toilet flushing, irrigation, laundry, and cooling towers. Cooling towers are a big one. They use a ton of water. So if you have a cooling tower, this is a great opportunity for you. We are focused on taking all of the waste heat out of wastewater and using that to preheat your domestic hot water system. So again, think about all your multifamily buildings, all the energy that goes into heating that water up. We shower in it for 10 seconds and it comes right back down the drain. Why not close the loop there? And then lastly, we can take organics out of the wastewater and produce high quality soil amendments as a byproduct. And so, as a company, we've gone about integrating those disparate kind of treatment modules into a common system that we lovingly call our One Water system that you're seeing here. And our focus is really, how do we make these systems as compact as possible? Because we all understand that, we need to shoehorn these systems many times into the basement of a building or into a parking garage. So being as compact as possible is obviously beneficial, but it's also being energy efficient. And then being efficient on the life cycle costs. And that comes through automation. How do we lessen the requirements for O&M on these systems? And that's one of our key strategies there. And then also, last but not least, creating a system that can kind of scale with your growth. We work on a lot of district scale projects where, over time, the development will grow. Great, let's design a system that can grow with your business. So that's the kind of high level package that you're seeing here. In terms of what comes out of it, as I mentioned, there's the water piece. So just some rough rules of thumb. If it's a commercial building, we can reduce water use by as much as 90 to 95%. That's mainly because most of the water used is for non-drinking applications. It's the cooling tower, it's irrigation, and it's toilets. In a residential setting, we can reduce water use by around 50%. Again, because there's a lot more in the way of potable water. We need to provide city potable for drinking, for showering, etc. So that'll give you kind of the rough contours in terms of how much water we can save, between 50 and 95%. We mentioned the soil amendments. So we actually got our start with the Bill and Melinda Gates Foundation and the Reinvent the Toilet Challenge. I'm sure some of you have heard of it, but that's what led us to developing this technology. And the main benefit to projects is, one, we can close the loop, obviously, in terms of all this rich organic material. But two, it has benefits to the downstream treatment system and allows the system to be smaller, more energy efficient, which are two really big drivers for a lot of our projects. And then lastly, we talked about heat recovery. So again, rough rules of thumb, you can recover around 24 kilowatts per day per 1,000 gallons that are treated by the system. Oftentimes we're dealing with 30, 40,000 gallons a day system. So there's a tremendous amount of energy that we can capture and repurpose. And this really kind of came from a very interesting statistic. The US Department of Energy estimates that throughout North America, we waste 350 billion kilowatt hours of energy to our sewers each year. Huge, huge opportunity, huge number. When you get your pen and pencil out, for those who are following along at home, that's enough energy to power every electric vehicle ever made. So just tremendous opportunity, one that we're seeing more and more cities capitalizing on and more buildings capitalizing on as well. And then, of course, we need to find ways to do this affordably and reliably for our owners, which led us to develop one of the best SCADA systems, which, SCADA is a tool for instantaneously monitoring the performance of the technology and then all the key outputs in terms of water saved. And so we've developed not only all the automation controls, but then these cloud connected dashboards that allow you to connect other water uses within your building to our dashboard so you can plot that out and see how water is being used in real time. And then most importantly, you can trend it over time. So you can see how your landscape water use has changed from month to month, year to year, which will help you identify issues with broken pipes, leaks, et cetera. And again, these are not costly technologies, but they go a really long way to helping us save every drop that we can. We can't do much about leaks if we don't know what's happening in the line. And this is one of the key strategies we can offer to help provide that level of insight. So that's kind of your big picture technology package. I'm going to turn it over here to Megan to talk a little bit more about how this is happening in Austin, because there is a lot of new development in your market that closely models the work we've done in other regions. So with that, Megan, if you'd like to take it away.
Thanks, Eric. And I am based in Austin, so this is something I'm pretty darn familiar with. I worked very closely with Austin Water, kind of going through all the movements on how things have been changing over the last couple of years here. So I'm excited to share it with you all. Before we get into the Austin specific piece, I just wanted to talk a little bit about how this plays out on a statewide level. You'll see there in the graphic, we've kind of cordoned off the Austin area. And the reason for that is that their permitting process is a little bit different. They have something very specific going on. And permits go specifically through Austin Water for any of these on-site water reuse systems. The exception there is for a Blackwater on-site reuse system. That is something that would go through Austin Water and TCEQ. As soon as you get outside of Austin, the rest of the state is going to have permitting that goes through TCEQ at the state level, and then also through your local AHJs. So what that really means is that the local plumbing code is going to govern in those situations outside of Austin. A high-level permitting framework may look like getting a mud application, going through your typical wastewater treatment plant permitting cycle, which usually takes around a year, getting your TLAP or whatever applies there. And the important piece is for that on-site reuse, you do need a beneficial reuse authorization. So let's go ahead and look at what things look like specifically in Austin now. So we've got two different date ranges here. One is before December 1st of this year, and one is after December 1st. So what's happening on December 1st? December 1st, this ordinance is going into place, which will require all new buildings over 250,000 square feet to have on-site water reuse systems. There is currently some types of reuse required. So you can see there we have condensate for cooling tower makeup is required right now. But after that December 1st timeline, there's going to be a requirement to use some combination of rainwater, condensate, and gray water for end uses like toilet and urinal flushing, irrigation, cooling towers, and laundry. If it sounds like I'm being vague, that's because I am. The official language for this ordinance has not yet been released. Austin Water has been pretty tight-lipped about it, but it will be coming out here in the spring or summer of this year for stakeholder input. So keep your eyes open for that one. Something that's pretty awesome that Austin Water has put into place recently as well is an incentive program where on-site reuse systems can get up to $500,000 in assistance through Austin Water. So that means if you went and signed up to do a project right now, you may be able to get up to $500,000 towards your project. After this ordinance comes into place, we're not exactly sure what's going to happen with that incentive program. It sounds like there's a possibility that it will stick around as more of an above and beyond program, meaning if you meet the minimum requirements of the ordinance, but you decide to do more on-site reuse, then you may still be able to get some funds from that incentive program. So again, not sure what that one's going to look like, but we are hopeful that it's going to stick around in some form. Okay, and now we can look at what that specific pathway is like for an on-site reuse system getting permitted in Austin. Essentially, there's a separate application process which requires a water balance and an engineering report that's prepared by a PE. So those items would be submitted to Austin Water. There's one other piece of information that's needed for district scale projects. Essentially, all of that information is going to go through your typical construction document review with the city and Austin Water. A plumbing permit would be issued. That's when you would be able to go ahead and install the system, complete any construction inspections. And then if everything looks good, it works as expected, you would obtain an operating permit for that reuse system from Austin Water. From there, it's really just your ongoing O&M for the system and any occasional inspections that may be required by the city. So I think we're back to you, Eric.
Great, thank you, Megan. Yeah, so there's a lot that's going to be changing, certainly in Austin. One thing I just wanted to point out is that you're not alone. This is happening in a lot of the major cities around the West in terms of ordinances, regulatory frameworks that are helping to open the door for owners who want to recycle their wastewater, and in some cases mandating it as well. This really kind of comes from maybe where solar was 15 years ago, where a lot of owners kind of want control of their destiny in terms of that water supply, in terms of the amount of money they pay on an annual basis for those services. So, as I mentioned, in relation to solar, I think this is going to be very, very similar, where this is kind of a new trend, but one that is really a sign of what's to come. And so, yeah, in terms of the permitting, there is a lot to take in there. We're totally sensitive to that. But, that's what leads us to provide kind of a one-stop shop approach here at Epic. So, for our clients, we'll do all the engineering reports, we'll stamp them, we'll submit them, we'll work hand in hand with our regulators to get these systems approved. And then really importantly is we'll work with designers in terms of the mechanical, plumbing, electrical engineers to help make sure that the building is kind of water reuse ready in terms of HVAC systems, ducting, making sure there's no odors, of course, as a byproduct of treatment. Making sure that we have the right type of electrical service, waterproofing, all of that, drains, sumps. There's a lot of little details, but rest assured, we're here to help. And then we can even do the ongoing O&M, so we can be that long-term partner. These are all kind of optional services. An owner also has the option to just procure the technology. That's fine for us too. But our real goal is just to make this as easy as possible and really streamline that process on behalf of the owners. So kind of backing out just a little bit as we're going to go into some details on the technical side. I just want to make sure we're all on the same page in terms of definitions. I'm sensitive to the fact that this is new technology in your market. So some level setting on definitions. Greywater and Blackwater. I see it confused all the time. I get it. But the main distinction is that, Greywater is very specific wastewater from showers, hand washing, like bathroom lavs, and laundry. Blackwater is any water that's been commingled with wastewater from a toilet or from like a food preparation area. That could be your dishwasher, your kitchen sink, utility sinks, because of its higher potential for contamination. Then you have rainwater and stormwater. Those can get intermixed as well. Rainwater specifically is precipitation that falls on your facade. Stormwater is anything that's collected at or below grade. And the main distinction there is once it's collected at or below grade, we have to consider the potential for hydrocarbons, the leaky oil transmission under your car, the potential for dog doo-doo that's kind of now part of that runoff. So those are the key definitions on the wastewater side. We also then have on the distribution, we have our potable water, which is what we drink, and then our non-potable water or recycled water is what we provide as an output of the system. So in terms of getting into the details on any given project, our first step is really to look at the development and figure out what is the best strategy to get to where we're trying to go, right? We need to work with the owner, understand their goals, and understand a little bit more about their building. And so that includes looking at the overall building program, total number of gross square feet, if it's a commercial office or unit count, looking at the number of bedrooms, right? And with that, we have our own tools that can help us forecast how much water is going to be used in the building. Do we have a cooling tower? How much irrigation space? This is all very early planning, kind of high level concept numbers, but it helps us kind of narrow in terms of what's the demand for recycled water. And then we pair that with, well, how much wastewater is this building actually going to produce? Do we need to treat all of the wastewater? Or can we maybe treat half of it? In the case of most residential projects where, we can only reduce the water use by 50%. And let's say there's no cooling tower. So yeah, only a portion of that flow is going to come through the system. So once we have those details, we then start to look at what's the best strategy on behalf of the owner, taking into account all the costs for doing on-site reuse, both our costs to deliver the project, but then also installation, right? And those installation costs vary depending on the type of approach we're going to take. A key example of that is Greywater versus Blackwater, and we're going to get into that here. But the thing to point out is that, if we're doing Greywater, we have a separate set of collection risers in the building that need to be accounted for. And, the general guidance right now is Greywater is pretty much where the market's going to go in Austin for the time being, as Megan was referring to. There's still some work being done at the state level in Texas to enable and hopefully open the door for Blackwater. But, our current guidance for that market, for the Texas market is, Greywater is really the best fit today. And, we'll kind of see how things pan out on the regulatory side. And as we eventually and inevitably, in my opinion, move to Blackwater, which is kind of what we've seen here in California. It started as a Greywater market, and before long, most of your work ends up becoming black water projects. And that just comes back to the efficiency of your building systems. If you do black water, you have a single, it's basically an unmodified sanitary collection network. But when you do gray water, you're doubling it up. So something to take into mind. And again, that's something we can help with in terms of penciling out the costs. But as we kind of get further into the weeds here on the technology side, I just want to give you a really high level kind of process overview in terms of what is actually happening in the wild world of wastewater. So what you're seeing here is a quick diagram. We can talk about gray water and black water actually at the same time. I'm going to flip between two slides. And what you're going to see here on the left is that really the only thing that changes is our method of pre-screening the wastewater. So in the case of black water, we have the option to collect all that rich organic material and produce a soil byproduct. It's not mandatory that we do that. It's just an option we like to provide to the owners. If we're not doing that, then our pre-screening approach changes slightly. Whereas instead of going to a very fine level of filtration, we're really just focused on all of the coarse material that is in the wastewater that shouldn't be. Or maybe it's hair and lint, trying to get these things out before they get wrapped around impellers of pumps, put into tanks where they then need to be kind of pulled and scraped out. A key distinction too is that a lot of our projects, especially in the urban corridor, have municipal sewer service at the property line. So we typically advise, hey, let's have the connection to the utility. It's a fail-safe mechanism that's obviously super reliable. And why not? We can manage it 100%, but in most cases, there is a utility backup. We install a three-way valve that is basically spring return closed. So in the event of a power outage, boom, everything, that valve by default spring returns to send everything to the sewer. This is a great reliability feature in terms of making sure that nothing out of the ordinary happens in terms of backing up, the basement of your building. Of course, too, you'll have sumps and drains in the basement as a duplicate measure, but frankly, those things will be there as a contingency measure and hopefully never really be used outside of collecting and distributing like foundation drainage or little drip leaks as they may occur. From there, once we've screened out all of the organic or coarse material, we store water in a tank. It's referred to as an equalization tank. And what that does is kind of buffer out the surges of wastewater supply you're going to see in a multifamily setting in the morning when everybody gets up and showers and gets ready for work. And the key strategy for us then is it allows us to treat that wastewater even keel over 24 hours, which then means your system can be smaller. We don't have to size the system for peak instantaneous capacity. We can size it on an average basis, which is a great fit for the owner in terms of reducing the capital costs for the system. So now getting into the deeper weeds with the technology. So if you've been in the wastewater industry, this is going to be very commonplace. The technology we're working with here is called a membrane bioreactor. They've been around since the 80s. There's probably hundreds of thousands of them around the world globally. Obviously, I don't have a list, but very commonplace. I'm sure most utilities actually own one. It's kind of the workhorse of the wastewater industry in terms of producing very high quality treated effluent. And so membrane bioreactor is basically mimicking the microbiomes in our gut to break down all the organic material. We're leveraging bacteria that just eats it up. And then we're using membranes, which are 1/1000th the diameter of a human hair. So super, super fine filtration. And what comes from that is basically a very clear, crisp, no, turbid material effluent that then we disinfect. And the disinfection step is key when dealing with our public health officials because we need to make sure everyone's safe and that nobody gets sick. These technologies have been studied hundreds and thousands of times over. And what you're looking at here is chlorine which has the advantage of both disinfecting, but then also you get a disinfection residual that then helps keep your distribution system clear. Chlorine is what every major municipality uses around the country. It's what yields, a little bit of taste in your tap water when it comes in the building. And then we couple that with UV disinfection, which is basically shining lights that irradiate and inactivate all the pathogens from virus, protozoa, and bacteria. And once it's been through that two-step disinfection process, it's then stored in a tank. And that tank, again, helps us, is basically a battery of fresh water that can be pumped up into the building. And that tank helps us buffer out now surges in demand, where, when your cooling tower is going to kick on and draw a whole bunch of water instantaneously, or your landscape cycles are all going to kick on at once. Great, we've got a nice reservoir in the building that can be drawn on a 24-hour basis. So in terms of what that actually looks like, right, these are a lot of disparate systems. It's a couple of tanks. You saw the 3 tanks. There's the typical layout. You have the skid that houses all the membranes, the disinfection, and then you have simple skids for storage of chemicals. Just per OSHA, good to have on hand. Safety eye wash, lab sink, that kind of thing. But all said and told, we can really kind of start to squeeze all this into a mechanical room. You can also do cast in place concrete tanks, which are super efficient in terms of area use. You're seeing here on the screen all these cylinders. Well, they create a lot of voids in terms of unused area in the corners here. When those are cast in place tanks, they can go A to B to C, wall to wall. There's no more efficient way to manage the area needed for water storage than cast in place concrete. And that's, again, an area where we can help. Perhaps your waterproofing consultant's going to be, this is a new challenge for them, right? They're not used to dealing with wastewater in the building. We've seen it before. We're happy to help in terms of specifications for liner materials on those concrete tanks, if we can be helpful. So that's the wastewater wrap. Now we'll kind of get back into why this benefits buildings. We've got LEED, as we mentioned at the start, in terms of helping on the sustainability performance. So what you're seeing here, we can get you most of the way there, frankly, in terms of getting a LEED, becoming a LEED certified building. Our technology can be the difference between LEED silver, LEED gold, LEED platinum. And this really just depends on the type of solution we're looking at here. Obviously, for 24 points, you're going to need to do the full suite. But again, that's optional. We can kind of pick and choose and tailor this to your specific needs, depending on the project. And we'll share this as a resource. I don't think we have time to go through it in detail now, but the bulk of the credits come from water use. But we do claim additional credits for the solids recovery piece and for recovering all of the energy, all of that waste heat in our wastewater. So happy to work with you in terms of how we can help get you to the next tier of LEED, if that's of interest to you, in the event you say, hey, maybe this is a good fit for us in our project. We are also happy to help pencil out the financial performance of, let's treat this at what it is. It's an investment. And it's an investment that, frankly, isn't a one-size-fits-all solution in today's market. We tend to work mostly on larger buildings. We're talking hundreds of thousands of square feet, north of 100 or so multifamily units. And that's really just driven by the dollars and cents of where we can demonstrate a palatable ROI for our owners. And what you're seeing here is from a project we did in San Francisco. The key thing to note there is that San Francisco's utility rates are much higher. So getting to this level of, 3-year ROI would be very challenging in Austin, but not impossible in lieu of the grant funding opportunities you have here. So something to look at. I'd say most projects in Texas fall in the 5 to 10 year window. So, if that's kind of within your threshold of something that makes sense, we're happy to look at it. As I mentioned earlier, in relation to the water balance, all we need to know is, total building square footage, number of residential units. Tell us a little bit about your MEP systems. Do you have a cooling tower? Tell us a little bit about your landscape. Are we irrigating an entire park, or is this a zero lot line project? From there, we can get pretty sharp on our numbers from projecting water use, rolling together the costs to deliver the project, and own and operate that investment. And then we'll look at the utility rates. From there, it's pretty simple. We chart it all out, and we provide it to our owners as a free service, essentially, to kind of help guide them as to where this makes sense. And frankly, our goal, in recognition that this is not a one-size-fits-all solution, is to have the hard conversation early, right? We don't want to waste anybody's time getting excited, starting to design and spend money with the architects and designers to integrate these systems. Let's make sure we know what the financial performance is early on, so we make sure it's a fit for your building. Now, that said, there are a lot of other incentive programs out there. Again, I don't have time to go through all of them here, but would welcome that kind of outreach if we can be helpful in terms of how we can help bridge the gap on any potential funding challenges for the project. So, there are a lot of other things that we do kind of behind the scenes here at Epic. I'd say a lot of our work is in California, and I've been fortunate to have a front row seat in terms of how this market has evolved. And back in 2015, there was a day where every project, there was an ordinance, there was a sister ordinance to what you see in Austin that was issued in 2015 by San Francisco. Very, very similar. And in the early days, everyone, all the owners would say, "Oh, I got to talk to leasing. I don't know if, how we're going to sell this to residents, right? This is all new to us." And there was some concern, to be honest. I smiled because that has just completely evaporated. It took a couple of years. It took some conversations. But I think people quickly realized, for sure in San Francisco, is that really what they're creating is an amenity. We're seeing more and more people, choosing to follow their values with where they spend their money. And that's no different when it comes to selecting an office, selecting a residence, a rental residence. We see, I was fortunate to be involved in several large tech campus projects. Microsoft, Google did Blackwater systems. Facebook did a Blackwater system. Salesforce did a Blackwater system. It's really kind of and this is all part of their belief that, hey, this is what our workers want. If we want to attract top talent, we need to create these amenities for them. And that included amenities of green space in regions where there wasn't a lot of water. So, hey, we're going to have to recycle our water. Not only is it what we think our customers, being our employees, want, it's also just the right thing to do for us. So, that really changed a lot in California in terms of the yuck factor, right? What does this mean for my tenants? It's now not a question of, is there risk if I do this? It's is there risk if I don't? Do I want to be that building that just got built and is already outdated and everyone else did this, and I kind of missed the train here? Not only in terms of the option it opens in terms of water use for the building, but also on the utility side, right? So, we do a lot in terms of kind of helping connect the dots for owners. Another great example of this was our One Water brew. So we actually, we were fortunate to work with Related, one of the largest corporate developers in the country. They have a system at one of their properties in San Francisco. We partnered with them. We took our treated effluent off the system, and then brewed beer. And we like beer. I wouldn't call ourselves brewers by any means. We're talking about barrels of beer, and we're like, okay, sure, a couple barrels sounds good. Well, we ended up brewing 7,000 beers, which is way too much beer, if you're wondering. We still This was just in November. We took it to one of the larger sustainability conferences, Green Build. We threw a big party. It's been a lot of fun. And I can tell you that, it has really helped people say, well, okay, if I can drink the treated effluent in a beer, like what's the big deal if I put it in a toilet? So these are all things we do, to help kind of bring people along on this journey, which is a new endeavor. And then what you're seeing here on the left, we actually built an entire system and shipped it up there to San Francisco, where Greenbuild was held just this year. And we made a splash. This is certainly a showpiece, in terms of the technology, the aesthetics. We're trying to help move from a place where wastewater systems are seen as obtrusive, unsightly. What would I want in the lobby of my building is frankly the question we are trying to answer, and this is what came of it, and we're super proud. I think we're onto something here, certainly. We had Time Magazine pick us up as one of the top inventions of last year. So, when you kind of get to that scale, we're starting to see much more traction as opposed to maybe a niche technology in the market. That has led us to a number of really cool projects. I won't spend too much time boring you with the details, but as I mentioned, when we're recycling water, that does open the door to using water more creatively on your property, as you're seeing here in two of these projects that are adorning their building with all these living walls. It's just, we're so fortunate to be involved because these are industry leading projects. And really, we're thankful to have owners that are thinking so progressively and actively about, how they can do more with less in terms of their water use. So in terms of how we work on a given project, we do tend to get involved. Maybe this is just part of our initial kind of BD outreach, but during schematic design, right? And we can do that initial kind of feasibility. Hey, do we have space for this? Does it pencil financially? If you're not in Austin, we can look at the regulatory frameworks. How do we get this permitted? But from there, then once we get into DDs, CDs, we'll typically have a small scope to kind of help facilitate the integration process with your MEP engineers, your architects, to lay everything out, to make sure we got the right pipes coming in, the right pipes going out in terms of conveyance of that treated water. We have the right size breakers, all that kind of thing. And we can even turnkey design it. If you said, hey, this is a little nook that we want the system to be located, great. Pipe in, pipe out. You tell us where those are coming and we'll take care of everything in between. So very unique to us in terms of just, how extensive our service platform is in terms of just simplifying this and making this as easy as possible for our clients. So with that, I would love to point you to some great resources that are out there. On-site reuse, again, in Austin and Texas, it is new, but you're seeing there's a lot of really great articles and literature out there about how this market has unfolded in other areas around the country that have been doing it for a really long time. So I'd welcome you to join us on that journey. Take a look. There's a lot of great material, and you really want to thank everybody for joining us today. My goal was to wrap up a little bit early so we can save time for questions. There's usually a lot. I haven't been following the chat or the Q&A, but with that, I don't know, Chelsea, if you have some questions that have come in that you wanted to, I'll do my best to answer.
Yeah, we had one come in. Lisa asked if, with all the breweries in Colorado, is this helping drive the conversation for water recycling?
Yeah, absolutely. So, the big thing with breweries, I've worked with several. It's about the water use. There's a lot of water that's used for wash down of floors, for CIPs. What some breweries will say, who want to be very proactive, they'll use water for everything except for the final rinse. The final rinse and all of the sanitation process will come from the city. But, that's the minority of water use when it comes to CIP. So We can do a lot to save water. In terms of the major driver, what you see with a lot of breweries, especially microbreweries who are kind of growing up in small areas, is the impact they're having on the sanitation district. Brewery wastewater is incredibly high strength, and they pay a lot of money to discharge that wastewater to the sanitation district. In some cases, I've seen sanitation districts throw their hands up and say, "Hey, we can't take any more. You're gonna have to truck it somewhere." And my gosh, that gets super expensive super fast. So what we can do is essentially take, all of those costs off the table. We can treat everything locally, reuse as much of it as we can. In the event we can't reuse all of it, which is inevitable, we'll discharge at least highly treated water to the city sewer, in which case they're not going to be too concerned about overloading their utility system.
And there was, I believe you did have a slide on this, but are there other cities offering incentives like Austin? Maybe you can just highlight a few that that you know off the top of your head.
Yeah, my gosh, the list is long, so I don't know that I could in any way attempt to be comprehensive. I'd say really just reach out and let us know kind of where you are in the world. I'd say most major cities have some type of incentive related to water conservation in drought-prone areas. So sometimes we have to get a little bit creative. They'll have, incentives for changing your toilets or, removing landscape. What we found, I mean, at the end of the day, the goal is conservation, right? And the method for that has conventionally been change a toilet, take out your turf. What we can do is kind of reframe it and say, well, we're going to save this many gallons a day. That's equivalent to 100 toilets. So what can we do to unlock this opportunity? Because it's a win-win for everybody. So that is the one great thing about what we're doing is, we are providing win-win solutions. Everyone's around the same table in terms of, how do we take this pressure off our communities, off our businesses in terms of water scarcity, water stress. And so you'll find that a lot of people are willing to really get creative to help make these projects pencil.
Going back to the treatment process, can rainwater harvesting systems be integrated?
Yeah, absolutely. So, I'd say for our projects, we really look at, again, the holistic view. Where's the rainwater coming from? Are there regulations that mandate us to manage it in some specific way? We would provide a system that does both. Now, it wouldn't necessarily mean specifically that rainwater is going to go through the same system. Perhaps we're sharing parts of the system. But for example, you don't need biological treatment for rainwater. So it would bypass some portions of the overall treatment process, potentially use a common disinfection step. The reason for that is that you're going to just get better value as opposed to upsizing every component in the system to manage what is frankly a much less challenging water source. And challenging really isn't the right word. It's contaminated, right? We don't have the same pathogen loading in rainwater. So, with that, we put that on the table. The one anecdotal thing I can say about rainwater is, needing to look at the climate patterns, especially for much of the West. Rainwater can be a little bit difficult to pencil out in terms of rainwater reuse. And the big reason for that is that we don't get enough rain, and it only rains in certain seasons. So, I did a project for a tech campus. They wanted to be net zero water on a non-potable basis. We put millions of gallons of cisterns underground to collect rain in the wet season and then try to store it to get all the way through the summer and fall. If you were to look at that on a kind of dollars and cents basis, pretty hard to pencil that out economically because, burying all those cisterns is a lot. It's just expensive. So again, we're happy to do whatever works, whatever we have to do to kind of meet the goals of the project. But rainwater isn't always the most obvious opportunity. For me, Greywater is a great fit. You're going to have Greywater coming down that pipe 365 days a year. Whereas with rainwater, oftentimes what happens is you're only leveraging that investment 5 or 10% of the year. So you'll end up getting a better value. Yes, it'll be incrementally more expensive, but if you look at this kind of on a life cycle cost basis, in most cases, those larger systems with more reliable sources of wastewater perform better on a financial basis.
Another question of have we combined our system with a hot water management system like Teal successfully?
I have to be honest, I don't know what Teal is. So I can't necessarily answer that question. But in terms of integrating with a hot water management system, basically what we're doing is with the heat exchanger, pulling heat out of the wastewater and preheating the incoming domestic water. So from an integration standpoint, it's not super complicated. Really what we need to look at is what are the proximity physically between the heat source being the wastewater and where your hot water system is, and how do we be as efficient as possible to avoid losses in transferring that heat. And then also we need to look at, just generally, what type of hot water systems are we looking at here? Are they boilers? Are they heat pumps? Because, it really takes a specific project coordination effort to really figure out what's the most efficient way to leverage that opportunity.
Switching gears a little bit, how long does it typically take for a retrofit project to be completed with planning, installation, up and running?
Yeah.
And then I guess challenging that at a standard project of a new build.
Sure. Great question. So the long pole in the tent is likely to be the permitting. Getting the process design nailed down, doing an engineering report, submitting that, getting all the reviews and approvals we need. There tends to be two permitting tracks. You're going to have your typical building permit, as with anything else in the world that you would construct. That doesn't really change. There's not a lot of risk there. When you do on-site reuse, you tend to now have this extra layer in terms of the public health component. And that's where it can get a little bit technical, into the weeds on the wastewater technology. That permit can take more time. I mean, I can't, unfortunately give you a firm answer on that. What we tell people, as Megan referred to, is plan for 6 months. Sometimes it can take a year. I've seen it take longer. Now, the thing that we have working on our side is that in most cases, you only need the building permit to start construction. Really, on the permitting of the recycled water system, that's like a permit to operate. And so that allows us to get a little bit strategic. Let's start that permit to operate process right away, then start doing all the building permits, and all said and done, now we're kind of in that 6 months to a year window, hopefully. Our goal again is always to manage expectations. So do I think we could get something done in 6 months? Probably not. I'd say let's plan for a year. But with that, that to me seems like adequate time. It is a little bit aggressive, but certainly within reason in terms of getting this over the finish line.
Is there any way to remove amounts of PFAS in our systems?
Yeah, so PFAS, that's a big one. We've got some water folks in the room. So at the end of the day, we are an engineered system provider and integrator. We can treat for whatever is needed. I've had folks say, hey, can we do potable reuse? And, frankly, I've done that historically. I was involved in Pure Water San Diego, which is one of the most innovative, big utility projects. It all comes back to can we get it approved? Potable reuse, we're not there. So I'm sorry I even brought it up. But what I'm getting to is that, we can treat for anything. Our base technology is not designed to address PFAS specifically, but if there was a specific need for it, we're happy to engage in that discussion.
And we are almost out of time, but there's maybe 2 more questions I want to get to. So how do you handle pushback, if there is any, from owners or residents about using recycled water for laundry?
Yeah, that's a great question. I mean, I think that comes back to, all the work we do on the kind of PR front, right? And it's kind of twofold. You can have a technical discussion. You can show all the data about how this has been done for decades and it's safe, and here's all the great examples of it. What I found at the end of the day is that it's actually tends to not be actually a technical, concern. It's more of an emotional concern. And so that's where things like the recycled water beer have really been key. And then showing people, taking people on tours. Here's where it's happening in other communities. And look, talk to the residents. Are you happy with what you invested in? And with that, when you get people talking, I think that's really the key, is that open dialogue, letting people understand, we understand that this is new, and we would never fault anybody for questioning. I think, we should all question, new technologies, but I think really what unlocks things is most people aren't aware just how long this has been done successfully in other areas. So that's really, I'd say, one of the key strategies outside of like, hey, here's a 6-pack of beer, with the recycled water, we're drinking it. We're doing okay. So proof proof is in the pudding, I suppose.
Okay. So lastly, I guess if attendees have any questions about costs or estimates for their project or anything of that nature, what's the best way to get in touch with us and reach out?
Yeah, I've got I hope I don't regret this, but I've got my email here up on the screen. Feel free, Eric at Epic Cleantech, no H at the end of tech. And happy, we've got a great team here. We do our very best to respond, in a matter of hours, frankly. We've got some really sophisticated tools to help pull all this together. So right team, right tools, feel free to reach out and we'll do whatever we can do to help.
Great. I think if there's no other questions, we can end just a few seconds early.
Great. All right. Well, thanks everybody for joining us today. Really appreciate you taking some time out of your busy schedules.
Thank you all.
All right. We'll see you.